Welcome back to Astronomy. This is part 3 of chapter 1. We're going to look at the size of the universe. Bit of review from the last lecture. We talked about the farther away you look in space, the further back in time you're looking. So if we look at something that is very far away, 7 billion light years away, then we're seeing it as it was 7 billion years back in time. And we can look farther, look 12 billion light years away, and then we're seeing something that as it was 12 billion years ago when the universe was only about 2 billion years old. There is a limit to what we call the observable universe, how far we can see. Light from almost 14 billion light years away shows the universe as it looked shortly after the beginning, which is known as the Big Bang, before galaxies existed. But we can't see any farther than that because the light from anything farther away than about 14 billion light years has not had time to reach us yet. So beyond the observable universe, we cannot see anything farther than about 14 billion light years away. Let's talk about the size of the universe, and we'll look first in our local neighborhood in the solar system. So in the solar system, the most dominant thing is the sun. It is by far larger than anything else in our solar system. And remember what the solar system is. The solar system is the sun and whatever planets and asteroids and comets are in orbit around it, and the moon's going around those planets. And you can see the size comparison between the sun and the Earth. In diameter, the sun is actually 109 times larger diameter than the Earth. Now let's continue with this scaled down version of the solar system, scaled down by a factor of 5.8 billion. And the sun being a basketball, let's put it on the end zone of this football field. So it's a basketball right there. And we would put the Earth about 26 meters, which is about 28 yards away, as a little tiny rock, 2 millimeters in size, right there, where the blue arrow is pointing. And we could continue the scale of the planets because between the sun and the Earth are Mercury and Venus. So we'd probably put Mercury, a little grain of sand, right about here, and Venus maybe right about here. Continuing with that scale, if we were to continue walking, it would be about a 10-minute walk to get to our representation of Pluto. And then let's think about, but where are the stars? That's just where the extent of the planets, but where are the stars? So how far would you have to walk to reach the next closest star? Alpha Centauri is actually a 3-star system. And it would be the distance to Brazil, about 4,200 miles. So again, if we are representing our sun with a basketball, the Earth is 26 meters away from that, and we would have to go about 4,200 miles away just in our scale representation to get to the next closest star. And so the stars are much, much farther away than the planets are. There are over 100 billion stars in the Milky Way galaxy. So here's a painting of the Milky Way galaxy, and our solar system is roughly about where my marker is right there. But you couldn't see our sun and planets. They're so small on this picture. Remember, because there are about 100 billion stars throughout the Milky Way galaxy. If you wanted to count each one, counting just one star per second, it would take over 3,000 years just to count 100 billion stars. So many, many stars in our galaxy. And there's more than one galaxy. Back in the early 1920s, it was believed that the Milky Way galaxy was all there was, but now we know there are more than 1 trillion galaxies in the universe. And in this picture, taken by the Hubble Space Telescope, every one of these things that you see is a separate galaxy, and each galaxy has at least several billion stars in it. So as we contemplate the stars of the universe, how much there is in the universe, how big is the universe? The Milky Way galaxy is one of more than a trillion galaxies. And there are roughly 10 to the 11th, so that's 100 billion. That means a 1 with 11 zeros after it. 100 billion stars per galaxy times about a trillion galaxy, and that means 10 to the 23rd power stars in the universe, our estimate. So 10 to the 23rd power, that means it's a 1 with 23 zeros after it. It is a tenth of a trillion trillions. There are more stars in the universe than there are grains of dry sand on all of Earth's beaches. So the universe is huge. And that is the end of this very brief video on the size of the universe. Have a great day.